Good morning, everyone. Today is July 29th. It's Tuesday. It's our second day of class. So let's get started. Just a reminder, always check the announcements page for any updated announcements. I didn't post today's announcement yet. I'll usually post it after class or maybe before, but essentially all I'm doing is going to the course outline, scrolling all the way down until I go to today's date and figuring out what we're learning today. So today we will be working on 1.4, trigonometry and right angles, and you have two quizzes that are due today. So make sure you complete them by the deadline. Some of you have already completed them. Amazing. Good job. All right, so let's get started. Just a reminder, all our work is under the content section. Go to Unit 1, Lesson 2, or Unit 1, Lesson 1.4. Okay. So today's agenda. Minds on activity, learning goals and success criteria, sides of a triangle, Sakatula, problem solving today's work, reminders and questions. Label the sides of the triangles using sine, cos, and tan. So what question is asking you to do is to write the three trig ratios. If you don't know what they are, this is all from grade 10. You're supposed to write sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite. Oh, sorry about that. Thank you for. So the question asked us to label the sides of a triangle. So there's three sides of a triangle using the three primary trig ratios. So we have sine, cos, and tan. How do we do that? Very simply. If this is our angle, the side that's opposite to the angle is called our opposite side. The side that is the longest, also the side that's opposite the right angle in the triangle, is called the hypotenuse. Hypotenuse. And then the last side, which is also the side that's beside the angle that we're, I guess working with, is called the adjacent side. This is how you do that. Let's do this one more time. Remember, the side opposite the angle is called the opposite side. The side that is opposite the 90-degree angle, or also the longest side, is called the hypotenuse. And then finally, the side that is adjacent or next to, wrong angle from here. This is our angle. Yes, opposite. You got it, baby. All right, so this is the adjacent side. So this is how you label a triangle when it comes to trigonometry and primary trig ratios. All right, label the sides of triangles. Yeah, we did that. Now let's find the value of each trigonometric ratio using a calculator. So I would like everyone to, at this point, if they can, you should have a calculator, especially if you're doing math. There are calculators you can Google So I want you to grab your calculator, please. And we are going to do this. So the question was, what's sine of 12? Sine of 12 is
opposite.
Yes, opposite. You're right. Is 0.208. We're going to keep 3 decimal places.
Big bird.
Yes.
It's big bird.
It is a big word here, right? All right. 0.208 is sine 12. This is just a calculator exercise. There's really not much thinking to it. This is just to make sure that you know how to use your calculator and you're inputting the buttons correctly. For some calculators, you need to type or input the number first and then the sign or close button. For some calculators, you press the sign button and then put the number. To figure out what's your calculator, how to use a calculator. The next thing is close 52. Close 52, and that is 0.615, but we're going to round it to 616. Another important thing to note is if your calculator is set up in degrees or radians. So RAD is not what we want. I don't think you will ever use this, especially in our course. That's something more that we learn, that students learn in university and grade 12 university calculus and advanced what's that word? Advanced functions. So we will be using degrees. So make sure your calculator is set in the degrees mode. So right here in my calculator, you can see rad degrees, and rad will change all the numbers. We do not want RAD. We want DEG. That's important to note. Oh yeah. So tan 51, very simply, what is tan 51? Plug it in. 1.23. I guess one more decimal place. 4. That rounds up to a 5. Okay. So once again, this was just a calculator exercise. Hopefully some of you have calculators and are trying this and are getting this right. Let's move on. Oh, there are the answers. Did I do it right? Oh, no, sorry. This is the next question. This is also a review from grade 10. It's a little bit more difficult than the previous question. All you have to do is this. They're asking us to use a calculator to determine A, which is angle A, to the nearest degree. Okay, so sine A is equal to 0.6027. How do I figure out angle A? Kind of like algebra when you have x on one side and you have to move numbers over or, letters over. In this case, we're kind of going to take the sign and move it over. But this is not like the simple case of numbers where you just add or subtract sign. It's still a bit different when you're doing it with sine close to tan. You're supposed to take the inverse sign. Like that. So when you take sine on the other side, it changes to sine -1. Now this is not sine to the exponent -1 or sine to the power -1. That's different. This is also a button on your calculator. So before I solve this, I'm going to rewrite all of them in the correct way that I will be putting it into my calculator. So all I'm doing is I'm taking sine, cosine, tan, move it over, and they're all becoming sine -1, cos -1, and tan -1. The number is not changing, a is not changing, nothing else is really happening. And once you have it written like this, all you need to do is go back to your calculator and type it in. But you probably don't see that button on your calculator. There should be a second function button that on your calculator that will be the exact same as the sine button, but a little bit above it. You should say sine -1. So it looks something like this, sine -1. So everyone has this button on the calculator if you have a scientific calculator. So sine -1, 0.6027. Okay, the answer is 37. 37. 37 degrees, because we're always dealing with degrees in this course when it comes to angles. Okay, let's continue. Cos, but it's doing cos -1. So cos -1, and the number is 0.6129. The answer is 52. 52 is the answer. For the last one, I want you guys to try and solve it. Okay, so the answer was 89. Let us continue now. It's pretty straightforward, right? Sine, cos, tan, and then the inverse of sine, cos, and tan. So, learning goals. By the end of this session, you should be able to solve for unknown angles using the trig ratios and solve for unknown sides using the trig ratios. Success criteria. If you're able to label the sides of a right angle triangle, given a reference angle, and identify the 3 primary trig ratios, it means you're on the right track. Now, what are trig ratios? Once again, review from grade 10. So hopefully most of you have seen these before. But we're specifically going to be talking about right angle triangles. So what is a right triangle? A right triangle is a triangle where one of the interior angles measures 90 degrees. The side across from the right angle is the hypotenuse. The side across from the reference angle is the opposite side. And the side that forms the reference angle with the hypotenuse is the adjacent side. I've already explained this to you initially, so this is just putting it in writing. A right triangle is a triangle where one interior angle measures 90 degrees. So this is 90 degrees, the square box, this corner, that indicates 90 degrees. Label the sides of the following triangles. So I want everyone to put... Okay, everyone, let's get started. So hopefully you were able to label some of these. So your starting point is always from the reference angle or the angle that's given. It's never from that square box, unless if you're trying to find the hypotenuse. So I always start from the angle, go across. That means x is opposite. Across from the right angle, or the 90 degrees, is hypotenuse. And then the final one is your adjacent side. We're going to do the same thing over here. We take the angle